Well, let's see if I can talk a little bit tonight about dividing polynomials. And this is the material that I will not be covering in class. You're expected to watch this video and do the homework problems over the weekend and come to class Monday prepared if you have any questions on the homework problems that you couldn't get answered in the discussion board. So yes, feel free to post your questions in the discussion board over the weekend. I'll get to as many of them as I can. And if you have any more questions on Monday, we'll do that. Otherwise, we'll continue in section 3.4. So we use long division to divide polynomials, and just to remind you of what long division is like, you remember that when you have a long division problem, and here's one, it's 38 divided by 7, there are alternate ways to write that. You can write 38 and then use the old division symbol, divided by 7. The division symbol kind of reminds us of a fraction. There's a little dot on the top that's like the numerator of the fraction, and then there's a horizontal little line, and that's like the fraction line, and then there's a little dot on the bottom. So the division sign reminds us of a fraction, and in the fraction, the 38 is the top number, and it's the first number when you write the division problem in this way, and the 7, the denominator, is the second number. Now, the numerator of the fraction is called the dividend, and the denominator of the fraction is called the divisor. And the whole number part that you get when you do the dividend divided by the divisor, the whole number part that you get is called the quotient. And the piece that's left over, you write as a fractional part over the denominator that's the same as the divisor. And that part, that fractional part, is called the remainder. So when we do long division, we write the problem this way, and it's interesting because we write the 38 inside of this little this little roof thing, and we write the 7, the divisor, outside. So notice that the order changes. But it means the same thing when you write it this way as when you write it like this. So 38 divided by 7 is written this way, and 7 goes into 38 5 times, and 5 times 7 is 35. And so we have, when we subtract, we have 3, and there isn't enough in 3 to make another group of 7, so 3 is the remainder. And we write the remainder as a fraction, and the fraction here would be 3 over 7 because 7 is the divisor. So we have 5 and 3/7. We can write it as a mixed number, 5 and 3/7, like that. But if you multiply the 7 times the 5 and then add the 3, you get 38 over 7 again. So it's just a basic division problem. So, but we review that because I wanted to have you understand that when we use this division algorithm here for polynomials, we're essentially doing the same thing, except our divisor is a polynomial, and our dividend right up here, the numerator, is a polynomial, the denominator is a polynomial, the quotient is a polynomial, and the remainder is a polynomial. So it's the same idea, it's just that now instead of dealing with numbers, we're dealing with polynomial functions. So the names of the parts of the division problem are the same. We still have a dividend, a divisor, and we still have a quotient, and we still have the remainder. And we write the remainder over the divisor in fraction form like that. So we can then take this equation that I've all marked up right here. So let me take all these marks off. We can take this equation right here, and we can solve it for p. If you solve it for p, then that means that we're solving for p of x. That means you're going to have to multiply by d of x. We have a d of x right here. We do have a nice d of x right there. So multiplying by d of x will make a nice simplification. If you multiply this first term by d of x, the d of x's cancel out, and you're left with p of x by itself. Then you have to multiply every term on the other side by d of x, so you'll have q of x times d of x. And when you multiply this times d of x, those d of x's reduce to 1, leaves you with r of x. And so that means you can write your polynomial as a product of the divisor and the quotient, and then just add on the remainder. And that's really how you check your division problems anyway. You check your division problems by taking the quotient, which in this case is, in this problem here, the quotient is 5. If you take 5 and multiply that times 7, you get 35. And then, if you add 3, you get 38. and 38 over 7 is what the original fraction was. So the division algorithm is just telling you what you already know. That's how you check a division problem. The polynomial is equal to the divisor times the quotient plus the remainder. So we have these examples, and let's just see how this long division process works. The long division process isn't something that we'll do for very long because it's tedious and it's really not necessary. We have shortcut methods that work much better. But let's just show you how the long division works, because if you understand long division, you'll understand the simplified process much better. So we're going to divide p of x by d of x. And so that means that d of x is on the outside. X plus 3 is d of x. And p of x is on the inside. P of x is x squared plus 4x minus 8. So we're taking a polynomial of degree 2 and we're dividing it by a polynomial of degree 1. So that means that the answer polynomial will be of degree 1, because we have to multiply something of degree 1 times something of degree 1 to get something of degree 2, because you add exponents when you multiply, all that sort of stuff. So what we do is sort of the same thing we do when we divide with numbers. We think of how many times just x, what we have to put, so that for x times what do we get x squared? Well, clearly x times x is x squared, so we write that x up here. With polynomials, we don't have to worry about place values like we have to do with numbers, so it really doesn't matter where up there you write the x. So I just wrote it there. Now we have to use the distributive property and multiply, because that's what we do when we do long division with numbers. We take whatever number we wrote up here and we multiply it times the divisor. But we have to multiply it times both the x and the 3 because of the distributive property. We're multiplying two things that are added, so we have to distribute. So that's going to give us x times x is x squared, and x times 3 is 3x. So now we're going to subtract. So I'm subtracting the x squared and I'm subtracting the 3x. So now I get the x squared added to the negative x squared. That gives me 0. And we're going to add the 4x and the negative 3x, and that's going to give me x. And now our next number up there is 8, so we write x minus 8. Okay, now we do it again. We say we need to divide this x into this x. So we have to write here plus 1, because now we have to multiply. The distributive process applies once again. 1 times x plus 3, of course, gives us x plus 3. And now we'll subtract. So we'll subtract x and we'll subtract 3. Again, these x's here are going to add up to 0, and so we have negative 8 minus 3, which is negative 11. And that's our remainder. X doesn't divide negative 11. So that means the remainder is negative 11, and we're supposed to write the remainder over the divisor. So we have x plus 1 plus the remainder, negative 11, over the divisor, x plus 3. So that's how that works. If you want to, you could write x plus 1 minus 11 over x plus 3. That actually looks a little bit tighter. So either of these would be acceptable. Okay, the next polynomial is, let's see, sorry about that, is 3x squared plus 5x minus 4. So let's go ahead and work on that one. So 3x squared minus 5x minus 4 divided by x plus 3. So the x plus 3 is the divisor, so it goes out, and we're dividing 3x squared plus 5x minus 4. Alright, so we have to put something up there that when we multiply times x, we get 3x squared. So that has to be 3x. I know it's 3x because 3x times x is 3x squared, and 3x squared is what I have to get. So I can subtract it. Now the distributive property is in effect because when I'm multiplying this 3x times a sum, so that means I have to multiply times each term in the sum. That's the distributive property of multiplication with respect to addition. So 3x times 3 is 9x, so here I have plus 9x. Now I'm going to subtract, so minus 3x and minus 9x. Once again, these add up to 0. Minus 5x minus 9x is negative 4x. And now my next number up there is a minus 4, so I bring it down. Now I'm dividing again. X and what is negative 4x? Well, I obviously need a minus 4. So now again, the distributive property is going to apply. I'm going to multiply that minus 4 times x, and that's going to give me minus 4x. And minus 4 times plus 3 is negative 12. Now I subtract, and when I subtract, that means I change this to a plus. Subtracting is changes to the opposite number, and change that to a plus. So now these add up to 0, and negative 4 plus 12 is 8. And that's the remainder. So I have 3x minus 4 plus the remainder, 8, divided by the divisor, x plus 3. Okay, so that's all. If you have to do all these division problems, I will let you work on this one. The only difference with this one is that the denominator has 3 terms, but you set it up the exact same way and just work it out and see what you can come up with there. I want to focus on the process of synthetic division, which is the shortcut process that we use for doing long division. So we'll do this division problem first. We'll do x cubed minus 8x plus 2 over x plus 3. And the first thing we notice with x cubed minus 8x plus 2 is that the x squared term is missing. So that is the first lesson of synthetic division, and for long division as well. If you have a missing term, you have to insert a coefficient for that missing term. So with synthetic division, we only work with the coefficients and of the numerator, and we only work with the 0 of the denominator. So let's see what that means. The coefficients of the numerator are, for x cubed, the coefficient is 1. For the x squared term, the coefficient is 0 because that term is missing. For the x term, the coefficient is negative 8, and the constant is plus 2. So these are the only numbers that we really need. As long as we keep these numbers in the correct order, we know that the first number is the coefficient of the degree 3 term, and the second number is the coefficient of the degree 2 term, and so on. Now, we want to divide this polynomial by x plus 3. And so that means we're checking to see if negative 3 is a 0 of this polynomial. Because if x plus 3 divides that polynomial and there's no remainder, that means you have x plus 3 times some polynomial that's exactly equal to x cubed minus 8x plus 2. And I'm not saying that there is, I'm just saying that if there is, then that means you have this situation. And so that means that negative 3 is 0, and that means that x plus 3 is a factor of this polynomial. So that means that when you use negative 3 here on what I call the shelf, I call that the shelf. So I say put negative 3 on the shelf because you're checking to see if negative 3 is a 0, because if x plus 3 is a factor of this polynomial, then negative 3 is a 0 of this polynomial as well. So that means we'll put negative 3 on the shelf, and now we'll just use the coefficients for our division process. So the first number here, the 1, becomes the coefficient of the first term in the answer. And that's what happened in the 2 examples that we worked earlier. The first digit in the answer, the leading coefficient in the answer is the same as in the quotient, is the same as the leading coefficient in the dividend. So we just write that one down. And to make it even better, we'll put a line right here because we're going to do some multiplying and adding. So now what we do next is we take the number here, which is 1, and we multiply it times that number, which is negative 3, and then we add that to this number, which is 0. So we have negative 3, we add that to 0, and we get negative 3. Now we repeat that process. We take this number, negative 3, multiply it times this number, negative 3, and now we add the result here to negative 8. So negative 3 times negative 3 is 9. So 9 plus negative 8 is 1. And now we do it one more time. And I like to put a double line. I don't know why I do that. It's just the way I was taught to do it, so just to remind me that this is the last number that I'm coming up on here. So I don't know why I do that. I just do. So now again, I repeat. 1 times negative 3 is negative 3, and you add that to the 2. So here's the negative 3. I'm going to add it to the 2. And what I get now is negative 1. Now, that's the remainder. Negative 1 is the remainder. And what are these other 3 numbers? This 1, this negative 3, and this 1? Those are the coefficients of the quotient. Now remember, the original polynomial is degree 3, and so the quotient must be degree 2. If you take a degree, you have if x plus 3 is a factor, you have to multiply that times an x squared in order to get an x cubed. So this coefficient, this 1 is the coefficient of the x squared term, this negative 3 is the coefficient of the x term, and this last one is the constant on the end of the polynomial. And so now what we know is that we have x plus 3 times x squared minus 3x plus 1, and then by the division algorithm, we know that if we take x plus 3 times x squared minus 3x plus 1, and then add the remainder, which is negative 1, we would get x cubed minus 8x plus 2. And you should try this out. You should actually multiply this out. Okay, do that on your own time, and then add that negative 1, and see that you get x cubed minus 8x plus 2, because that's what the division algorithm says you should get. So make sure you can do that so you can understand how this works. Just remember that it's exactly the same as when you take 38 and divide that by 7 and get 5 with a remainder of 3, that you write 3 over 7 like that. And remember how you check these problems. You take the 7, you multiply times the 5, and you add the 3. And that's what we did every time here in our synthetic division. We took the number that was here, we multiplied it times the number that was there, and we added it to the next number. So it's exactly that same process as simplifying a mixed number. That's called, you guys know this is called a mixed number right here, because you've got a whole number and a fraction part. So what you do when you simplify those guys is the same thing as what you do when you are working these synthetic division problems. You're multiplying and adding, just like here. So, I don't know, maybe that'll help you to at least remember the process. So now let's just practice another one. So we'll do the second one. The second one is x to the 5th power plus 3x cubed minus 6 divided by x minus 1. So remember, the 0 of x minus 1 is what goes on the shelf. So x minus 1 is 0 when x equals 1. So we put 1 on the shelf. The coefficients of the numerator, we have a 5th degree term. The coefficient is 1. The 4th degree term is missing, so we insert a 0. 3rd degree is 3. 2nd degree is missing, so we insert a 0. And the first degree term is missing, as it's 5, 4, 3, 2. The first degree term is missing, so we put another 0, and then the constant is negative 6. So I'm going to do this. I'm setting up my workspace now to do my synthetic division. Alright, the first number, the 1, just comes down because the coefficient of the quotient is the same. The leading coefficient of the quotient is the same as the leading coefficient of the dividend. So now we take the 1, we multiply times, we take this 1, multiply times that 1, and then we add that to the 0. So 1 times 1 is 1, and we add 1 to 0 and get 1. Now we repeat that process. 1 times 1, and we add that to 3. 1 times 1 is 1, and when we add that to 3, we get 4. Repeat. 4 times 1, 4 times 1 is 4. We add that, get 4. One more time, repeat. 4 times 1 is 4, add that to 0, and we get 4. Last time, 4 times 1 is 4, add that to negative 6, we get negative 2. Okay, so that means that we now have our quotient, which is, remember, we took a degree 5 and divided it by a degree 1, so we end up with a degree 4. So the 1 here is the 1 for x to the 4th, and that's for x to the 3rd power. And we have 4x to the 2nd power. The next 4 is 4x. The next 4 is a constant. That's the quotient. So we take the quotient, multiply that times the divisor, which is x minus 1. We add the remainder, which is negative 2, and that's equal to our original polynomial. Once again, I strongly recommend for practice that you multiply this out, add the minus 2, and see that you get x to the 5th power plus 3x cubed minus 6. Do that so that you can understand the division algorithm better and see why it works. It's the only reason for doing that. I will help you get started on the next one, or maybe we'll even do the whole thing. We'll just see. First, let's just clear this off. Okay, the last one is, doesn't have any missing terms, but this time the divisor is going to be a fraction. So, on the shelf we're going to put 1/2. And the coefficients are 2 for the x cubed term, 3 for the x squared term, -2 for the x term, and 1 for the constant. So I'm getting set up here. My synthetic division. So remember, the first one just comes straight down. So the 2 this time is a 2 for the leading coefficient. The leading coefficient of the dividend is the same as the leading coefficient of the quotient. Now we multiply 2 times 1/2. 2 times 1/2 is 1, and now we add to the 3, we get 4. Now 4 times 1/2 is 2, now we add to the -2, and we get 0. And 0 times 1/2 is 0, which we add to the 1, and we get 1. So that's the remainder. And these are the coefficients of 2 is the coefficient of x squared. 4 is the coefficient of x. 0 is the constant, so we have that. Then we have times x minus 1/2 plus the remainder, which is 1. If you multiply all this out, you should be able to get back 2x cubed plus 3x squared minus 2x plus 1. It's a good exercise for you to do, so you should do that. And so we end up with something called the remainder theorem. Now the remainder theorem says that if the polynomial p of x is divided by x minus c, then the remainder is the value p of c. That's really interesting. So that means that for our previous two problems, the remainder that we got would be the same number that you would get if you substituted the number that's on the shelf into the polynomial. So let's look at this one. Use synthetic division and the remainder theorem to evaluate p of c. Now, we could evaluate p of c the old-fashioned way. C is -1. We could do p of -1 and just substitute -1. We would have 4 times -1 squared. I'm just showing you this. Plus 12 times -1 plus 5. 4 times -1 squared is 4. And I'll add the 4 and the 5, and that's 9. And then minus 12. I should get -3. So I know that the old-fashioned way of doing this, I get -3. Let's use synthetic division. C is the number that I put on the shelf, so I put -1 on the shelf. The coefficients are none missing, so 4x squared plus 12x plus 5. Get all set up here. Okay, bring down the 4. 4 times -1 is -4. Add the 12, and I get 8. 8 times -1 is -8. Add the 5 and I get -3. Lo and behold, I do indeed get -3. So, that might just be a coincidence, but it seems that it was true this time. And I'm pretty sure it's going to be true all the time, because after all, it is called the remainder theorem. So the remainder theorem tells you that the number that you get as your remainder here is the same as the number you would get if you substitute your value into your polynomial function. So either one of those processes will give you p of c. You can calculate p of c by this method, or you can calculate p of c by doing synthetic division, whichever one you are told to do. Now, that leads to the factor theorem, which is really quite simple. Anytime x minus c is a factor of the polynomial, that means the remainder is 0. So we're checking to see if we get a 0 remainder. So let's use synthetic division. P of x, we're going to divide by, we're going to use c equals 1. So 1 goes on the shelf. And the coefficients, there are no missing terms, are 1, -3, 3, and -1. So we'll get this all set up. Okay, bring down the 1. 1 times 1 is 1 plus -3 is -2. -2 times 1 is -2 plus 3 is 1. 1 times 1 is 1 plus -1 is 0. Aha! I now have found that I can factor x cubed minus 3x squared plus 3x minus 1 as x minus 1, because I used 1 on the shelf, and so that means c is 1, so I'm showing that 1 is a 0, so that means x minus 1 is a factor. And the other factor, these are the coefficients right here. for x squared minus 2x plus 1. So that's really nice. And now what I see is that I can actually factor x squared minus 2x plus 1. I'm going to do a little bit more than what this one asks me to do. I'm going to go ahead and factor this other factor. So I still have this x minus 1 right here, but x squared minus 2x plus 1, that's a perfect square. That's x minus 1 squared. But now I have x minus 1 times x minus 1 squared, so I have actually x minus 1 to the third power. So I see that this polynomial p of x is the same as x minus 1 to the third power. So if you took x minus 1 times x minus 1 times x minus 1, you should get x cubed minus 3x squared plus 3x minus 1. So notice that you have a factor when the remainder is 0. And that also means that if we calculated p of 1, we would get 0. Okay, we'll do one more. This last one is, here we go, this last one is p of x equals this, and we're going to use 3. So synthetic division, 3 goes on the shelf, and so we could put the coefficients. There are no missing terms, 1, negative 1, negative 11, and 15. So let's get this set up. Okay, 1 times 3 is 3, and negative 1 is 2. 2 times 3 is 6, and negative 11 is negative 5. Negative 5 times 3 is negative 15, and that's 0. So now we have, let's just take this a step further. We only wanted to show that x minus c is a factor, so x minus 3 is a factor. And the other factor is x, these are the coefficients, this x squared plus 2x minus 5. Now I don't think we can factor x squared plus 2x minus 5. So this is as factored as we're going to get. We could find out what the other, we know that 3 is a 0, right, because x minus 3 is a factor, and vice versa. We know that since x minus 3 is a factor, we know that 3 is a 0. We also know that since we got 0 in our synthetic division, that 3 is a 0, and x minus 3 is a factor, and that's the other factor. So synthetic division is a nice shortcut. It helps us to get the complete factored form of a polynomial, and in the next section we'll work with factoring completely a polynomial with real number factors, and then for the final part of this chapter we'll finally learn how to factor completely by extending our number system and considering another new kind of number, but that's just shades of the future. So enjoy this video.